This is a walkthrough for the WJC Unit 2 calculator paper from June 2023. In order to benefit the most from this walkthrough, I would recommend either that you complete the paper beforehand, doing all the questions that you can, or alternatively, as we go along and the question appears, have a go, pause the recording, and then once you've completed the question, you can then play the recording again to check your solutions. Okay, so let's dive in. So we've got the formula list for foundation, we've got the area of a trapezium, so something we might need to refer back to later. Okay, let's have a look at question number 1. So question number 1 is asking us to calculate the sum of 8,732 and 6,482. Okay, the key to this is that sum means that we are adding the terms. Okay, so if you see this, we're always adding. So it's a calculator paper, no need for us to do it without the calculator. Let's pop that into our calculator and you should get the answer 15,214. Okay. Part B is asking us what number when multiplied by 69 gives the answer 345. So we've got some number, and when we multiply it by 69, we get the answer 345. Okay, so this question we need to work backwards, don't we? Let's see, if the opposite or inverse of multiplying is going to be dividing. So 345 divided by 69, pop that again into the calculator, and that gives us the answer 5. Okay, it's always worth checking. I think the answer is 5. Let's work it through forwards. So 5 times 69 does indeed give us 345. Okay, part C. We've got to calculate the difference between 9,756 and 8,932. So wherever we see difference, we are going to subtract. So again, in the calculator, 9,756 minus 8,932, and that should give you 824. Okay, so question number 2, probability. So we've got to choose the best expression from those given below to complete the following sentences. So we've got the probability scale from impossible all the way through to certain. Okay, so let's think about the statement here. I will eat or drink something this week. So in this case, it is certain that I will eat or drink something this week. For part B, I will roll a 7 when a fair 6-sided dice is thrown. So 6-sided dice, so it has numbers 1, 2, 3, 4, 5, and 6. No 7 on the dice, so therefore this makes it impossible that I will roll a 7. Okay, part C. So we're thinking about I will win a raffle if I buy 1 ticket and 400 are sold. So my probability is going to be 1 out of those 400, isn't it? And not impossible, but it's probably unlikely that I will win. Question 3 is asking us to circle all the fractions that are not equal to 2 over 9. Okay, so equivalent fractions. The easiest way to do this on a calculator paper is, so our first fraction is 22 over 9, isn't it? If we go to the calculator and clear the display, our calculator can help us quite a lot with this question. So if we pop the first fraction, 22 over 99, into the calculator, and if we simplify this, it will do it for us, basically. So that first fraction will simplify to 2 over 9. Okay. Make a note of that, and then if we work through all the other fractions, so 4 over 18 also simplifies to 2 over 9. You should find, if you make your way through these, that the ones that do not equal 2 over 9 is going to be 12 over 19 and also 42 over 79. Part B tells us to shade 1/5 of the diagram below. So again, we're thinking about equivalent fractions. So if we're going to shade 1 out of every 5, let's see how many we've got here. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2 rows of 10, that's giving us 20 boxes. So let's have a think about 1 out of 5. How many out of those 20? So if we look here, whatever we do to the fraction, obviously to the bottom of the fraction, we need to also do to the top. So we see here, this is multiplied by 4. So we're going to do the same to the numerator. That is going to give us 4 out of those 20 boxes. Okay. You could also, another method is if we divide this up into 5s. So 1, 2, 3, 4, 5. We can shade 1 out of every 5 of those boxes. So whichever makes more sense, we need to be shading 4 out of those 20 boxes. Okay, moving on. We've got to write down the special name of the following shapes. This one here is a cylinder. Let's have a count of how many sides we've got for this. So we've got 1, 2, 3, 4, 5. So 5 sides. That means it is a pentagon. Shape C, we have 2 pairs of parallel sides. They are not the same length, so this means that we have a parallelogram. Question 5 asks us to find the median of the numbers listed below. Okay, so the median is in the middle of an ordered list. Okay, so step 1, we want to order the numbers, and step 2, we want to find the middle number. Okay, so let's have a look. Which is the least number in this list? We've got 11. I think it's always useful to cross them off, stay organized. And then 13, 15, 17, 20, 22, and then 29. And even though we've been crossing them off, I'm just going to check that I've got the same amount of numbers that I started with. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so it looks all right so far. Let's find the center one. So we're going to cross off one from either end until I get to the center number. So my median in this case is going to be 17. So in the table below, letters A, B, C and D represent different numbers. The total for each row is given at the side of the table. And we're asked to find the values A, B, C and D. So if we start with row 1 here, we can see we've got A, and A. And if we total them or add them up, we get 120. So we know that 4 times A is going to give us 120. So if we divide that 120 into 4 parts, that's going to give us 30 for the value of A. Okay, so let's have a look at line number 2 now. So now we've got B involved, and we've got A here, which is 30, isn't it? A, which is 30, and A, which is 30. So we've got B plus 3 lots of 30 are going to give us 107. So let's have a look. So B plus 30 and 30 and 30 is going to give us 90. And that's going to equal 107. So in order to work out what B is, we are going to subtract 90. So B is going to be equal to 107 minus 90, and that's going to give us 17. Okay, so back to the question up here. So we've got now B, and C and another C, they're going to total up to 114. So let's fill these in. So for question number 3, let's put together our equation again. So we've got 17 plus 17. That's going to give us 34. Plus, this time we've got C plus C, 2C. And when we add those up, we're going to get 114. Okay, so in order to solve this, let's take away this 34, and that'll tell us what this 2C is worth. We're going to have 2C is equal to, so 114 minus 34, that's going to give us 80. So obviously we've got 2C here. So in order to work out C, we're going to divide that into 2. And C is going to be 40. So let's just update our little table here. So on to the last step. So we know already that A is 30, don't we? B is 17, C is 40. And then we've got A plus B plus C plus D is equal to 100. But for that space down here, so I'm going to move up to the top here. So, excuse me, let's work out 30 plus 17 plus 40. So if we add up those ones, it's going to give us 87. So we know that these 3 together add to 87. So if we want to work out D, we're going to take this 100, subtract 87, and that is going to give us 30. So D is 13. In an exam, obviously, it's good just to check that these values all work. So for row number 1, 30 plus 30 plus 30 plus 30, check that that adds up to 120. And so on for all the other rows. (7A). So what is the special name given to an angle greater than 0 degrees and less than 90 degrees? This is acute angle. What is the special name of a quadrilateral? So a quadrilateral has 4 sides with rotational symmetry of order 4. So rotational symmetry, what we're thinking about is if we've got a shape, we pin the shape in the center, we're going to rotate it a full 360 degrees. And we're going to see how many times is that shape landing on itself. Okay. In this case, it's going to be a square, so it's 4 equal sides, gives us rotational symmetry of order 4. Question number 8. We have to describe in words the rule for continuing each of the following sequences. So in this case, we can see that the sequence is decreasing, isn't it? It's going down. So let's just check, is it going down by a constant amount each time? Okay, so if we look at 62 minus 51, that's going to give us 11, isn't it? So to get from this term to this term, we're going to subtract 11. Let's just check that rule works for the next step as well. So 51 minus 40 is also going to give us 11. So we're subtracting again 11 here. So that's our rule for this is subtract 11 from the previous term. Okay, so let's have a look at the second sequence here. We've got 2, 8, 32, and then 128. So it's increasing. So let's have a look. If we go from 2 to 8, here we are adding on 6, isn't it? To go from 8 to 32, we are going to be adding on 24. So that's not a constant amount that we're adding on, is it? So let's go back to the drawing board. It's getting bigger, so let's have a look. Are we multiplying by a constant amount? So if we want to think about what do we need to multiply 2 by to get to 8, so we can do 8 divided by 2. That's going to tell us that we're multiplying by 4. 8 times 4 will give us 32. Let's just check that that works for the next step as well. So 32 times 4, 128. So my rule for this one is to multiply by 4. Part B, we are solving the following equations. So we've got x, we multiply by 4, and that gives us 124. So 4x means 4 times x, doesn't it? In order to work out what x is, we're just going to always do the inverse. So 124 divided by 4 is going to give us x is 31. For part II, we've got w, and we are adding 6.9, which is going to give us 110. In order to solve that, we're going to do the inverse or opposite of adding 6.9, which is to take away 6.9. So 110 take away 6.9 is going to give us w is equal to 103.1. Question 9 asks us to calculate 3/8 of 142. So if we think about 3/8, we've got 1, 2, 3, 4, 5, 6, 7, 8. So if we think about the fraction, what does this mean? We're going to divide it up into 8 parts, and we want 3 of them. So if we take 142, we're going to divide it into those 8 parts. Going in the calculator, that is going to give us 17.75. So each one of these 8s is going to be equal to 17.75. So if we want 3/8, 17.75 times by 3. And that's going to give us 53.25. This method will work for non-calculator as well. So obviously you would, rather than using your calculator, you could do your bus stop to divide by 8, and then non-calculator methods to multiply by 3. If you are using your calculator, another method is, so 3/8 of 142, we can replace that of by times. So if we pop that into the calculator, so 3/8 times 142, it gives us the fraction. If we press this button, change it to a decimal, gives us 53.25. So whichever method you are more comfortable with, work that one out. Moving on to part B. So another calculator question here. So we're going to evaluate 3.4 squared plus 31.36, and that's square rooted. So we're going to pop that straight into the calculator. So exactly as it is, so 3.4 squared is this little button here. And then we are going to add, so the square root button goes here, and underneath the square root we want 31.36. And so give us fraction, but it wants us to write the answer as a decimal, so 17.16. Okay, 1 mark questions, so no marks for workings here. Question 10. We are going to be assessed on the quality of our organisation, communication and accuracy in writing. Okay, it's quite a lot of information here, so let's just read through the question. So Steve has a bag containing 10 discs. I like to draw out a little diagram so I can understand what's happening. Some of the discs are red and the others are blue. So we've just got red and blue in this bag. So if a disc is selected at random, the probability of selecting a red disc is 2/5. 10 more blue discs are added to Steve's bag. He now selects 1 disc at random. And what is the probability that the disc Steve selects is red? And we must show all our workings. Okay, so let's go back. We've got the bag, haven't we, containing the 10 discs. We've got the probability of red is 2/3. So the probability of blue is going to be, the total probability is 1, isn't it? So 1 take away 2/5, that's going to be 3/5 is the probability for blue. So let's work out how many red and blue we have. Okay, so if we're doing, we saw from the fractions of amounts question, if we want to work out how many red we've got, we divide by the bottom and then we multiply by the top. So let's work this out. So 10 divided by 5 is going to give us 2, isn't it? And then if we multiply by 2, that's going to give us 4 red. Okay, so we're going to have 4 red counters. There's obviously 10, sorry, discs. There's 10 in the bag, so we're going to have 6 blue. Okay, we're up to this. Let's go back to the question all the time and reread it so that we know what to do next. So 10 more blue discs are added to Steve's bag. Okay, so let's have a think about how many discs have we got in our bag. So we started with 10 and we've added 10, so now we've got 20 discs. We've added 10 blue, so we've now got 16. And the red is going to be just the same, isn't it? We've not added any more red discs. So we want to think, what is the probability that the disc Steve selects is red? And we've got to show our workings. Okay, so let's have a look. The probability that he selects a red is going to be equal to. So on the bottom of our fraction, we want to think about how many discs are we choosing from. So we've got 20 in that bag. And then we want to think how many of those 20 are red. So the answer is 4. I'm going to leave my answer as 4 over 20 because it doesn't tell me to write my answer in the simplest form at all. Question 11. We have a polygon. It's got 1, 2, 3, 4 sides. So we've got a quadrilateral. We need to think angles in a quadrilateral. They add up to 360 degrees. You need to learn these facts. So 4 sides, the angles add up to 360 degrees. So we've got x, haven't we? We know the other 3 angles. So in this case, if we add up 97 and 42 and 115, that gives us 254. So what's left? So we take 360, let's take away 254. And that leaves us with x is equal to 106 degrees. In part B, we've got the diagram below shows an isosceles triangle, and we need to calculate the value of y. Okay, so an isosceles triangle, these little dashes mean that this side and this side are both equal in length. Because of the properties of the triangle, that means that this angle at the bottom here will be equal in size to this other angle y. So they're both equal. The other thing that I need to know is angles in a triangle. So angles in a triangle add up to 180 degrees. So what I'm going to do is I'm going to start with 180 degrees. I'm going to subtract this 78 degrees to see what the remaining angles add up to. And that's going to give me 102 degrees. I know that these are both equal, and obviously there's 2 of them, so let's divide that by 2, and that's going to give me y is equal to 51 degrees. Would be good at this stage just to do a little check, so y and y 78, let's just add 51 plus 51 plus 78, let's just check, does that add back up to 180 degrees? which it does. Question 12. So which one of the following fractions can be written as a recurring decimal? So a recurring decimal is something like, for example, 0.33333. This will continue forever. Okay, so with a calculator paper, what we need to do is, let's go to the calculator, enter in the first fraction, which is a half, and then if we press equals, it just gives us a half, but we can change that to a decimal. So what we're looking for is that repeating number. So obviously a half is going to be 0.5. That's not recurring. Let's try the next one. So next in our list is a quarter. That's equals. Let's change that. So that's 0.25. There's, again, no repeating number there, so that's not the one that we're looking for. And next one, 1/6. Let's change that. And we can see here this, we've got 0.16, and this 6 is just repeating 6, 6, 6, 6, 6. It would continue. The calculator's obviously rounded it at this point, but it would just continue on if the calculator display didn't stop here. Okay, so 1/6 is our answer for that one. So it's 0.16 recurring. We write that with a little dot over the number that keeps repeating. Part B is asking us which three numbers from the list below are prime numbers. So prime numbers have exactly two factors. One of those factors is 1, the other factor is the number itself. So what we're looking for is three numbers here which only divide by themselves and 1. The best way to go about this is just to eliminate those other numbers that have more factors. Okay, so for example, I can see this number 35. This ends in a 5, so I know it divides by 5. So that's definitely not going to be one of my primes. 55, the same, ends in a 5, so I know it divides by 5. Any even numbers I can cross off because I know they divide by 2, but I haven't got any of those. So let's have a check. Do my numbers divide by 3? So a little check that you can do. So for example, 27. If you add those digits, we get 9. If this number divides by 3, then we know that 27 divides by 3. So in this case, we know that 9 divides by 3, 27 divides by 3. So that we're going to get rid of from our list. 3 plus 1 gives us 4. Not divisible by 3. So that's remaining on our list for now. Let's do the same for 39. So 3 plus 9 gives us 12, doesn't it? That divides by 3. So we know 39 divides by 3. And let's go over here. 4 plus 3 is 7. Doesn't divide by 3, so that can stay on our list for now. 47, that gives us 11. Doesn't divide by 3. 51, so 5 plus 1 gives us 6. We know that divides by 3. So I'm left with 3 numbers. They must be my prime numbers. Always worth having a look over your prime numbers before you sit an exam. It's a topic that often will appear. Question 13. So we've got Alice is 9 years younger than Isaac. Nadia is 1/3 of Isaac's age. There he is twice Nadia's age, and Alice is 27 years old. Okay, let's start with Alice because we know her age is 27 years old. Okay, so we've got to work out what are the ages of Isaac, Nadia, and Zoe. So let's have a think how. Let's go back and read through the question again, because that was quite a lot of information, isn't it? So Alice is 9 years younger than Isaac. Okay, so in this case, Isaac is going to be, so if she's 9 years younger, he's going to be 9 years older, isn't he? So 27 plus 9, that's going to give us Isaac's age is 36. Okay. So let's go back and have a look at the rest of the information. So we've got Nadia is 1/3 of Isaac's age. So we know Isaac, don't we? So let's have a look. So Nadia is going to be 1/3. We're thinking about dividing it into 3 parts, aren't we? So let's take Isaac's age. We're going to divide it by 3, which is going to be 12. So we know that Nadia is 12 years old, which leaves us with Dewi. So Dewi is twice Nadia's age. Nadia is 12. So 2 lots of 12 would give us 24 years old. Okay, so we've got now, we want to write down the next 2 numbers in the following sequence. So let's have a look what's happening each time in this sequence. So to go from -26 to -20, the sequence is increasing, and we've got to think by how much is it increasing? It's by 6, isn't it? And if we add 6 to -20, we get up to -14. So that seems to be working for all the terms. So in this case, -8 add 6 is going to give us -2. And then if we add another 6 on, that's going to give us +4. Okay, part B. So F is equal to 3G. So 3 times G plus 2H. So 2 times H. We're going to calculate the value of F when G is equal to 9.3 and H is equal to -13.6. Okay, so it's going to be equal to 3 times 9.3 plus 2 times -13.6. You can put this straight into your calculator. It should give you the solution 0.7. Question 15. So a box contains different coloured balls. Some are red, some are blue, and others are green. The bar chart shows how many balls of each colour are in the box. And we are asked to draw an accurate pie chart to compare the number of coloured balls in the box. Part of the pie chart has been completed for you. Okay. So we could start with reading off, couldn't we, from this bar chart. So we've got, let's follow those missing numbers in, might be a bit easier. So red here is going to represent 2, isn't it? Blue is 5 and green is going to be 3. We want to work out what is the angle in the pie chart. Okay, so we can think about this, it'd be useful to think about this as a ratio. So red is going to be 2 parts, isn't it? Blue is going to be 5 parts. And we've got green is 3 parts. Okay, so in total, I've got 2 plus 5 plus 3. That's going to give me 10 parts. In a pie chart, I've got a complete circle, haven't I? So my pie chart is going to be 360 degrees in total. And what I want to do is I want to divide that up into those 10 parts. We pop that into the calculator. Each part of that ratio is going to be with 36. Okay, so my angle for red, I've got 2 parts, isn't it? It's going to be 2 times 36, which is going to give me 72 degrees. For green, I'm going to have 3 parts, so 3 times 36, that's going to give 108 degrees. Let's just do a little check. We've obviously got the angle here for blue, isn't it? It's half the pie chart, so 180. If I do 5 times 36, it does give me 180, so I know that I'm on the right track here. And then I haven't got a protractor here, but what we would need to do is pop your protractor on to here. We would measure 72 degrees, which is going to be approximately around here, and then we would need to divide this up into the angle for red, which would be 72 degrees, and the angle for green, which would be 108 degrees. Question 16. So we've got a journey of 45 miles. Is travelled in 1 hour and 15 minutes. And we've got to calculate the average speed of this journey. If we think about our relationship between speed and distance and time, we've got distance in the top of this pyramid, speed and time. So if we want to think about speed, if we cover that up, then we can see that it's distance here divided by time. So we've got speed equals distance divided by time. We've got a little bit of a problem here with the units. So we want to put our answer in miles per hour. This is in miles. This is in hours and minutes though, so we just need to convert this. So 1 hour, 15 minutes. Let's think about this 15 minutes. We want to change that into part of an hour. So if we divide that by 60, that is going to give us 0.25. So if we put that together, so 1 hour and 0.25, we've got 1.25 hours. Okay. So now we've got the correct units, we can pop that into our formula. So we're going to do 45 and we're going to divide it by 1.25 into the calculator. And that's going to give us 36 miles per hour. Question 17. A solid metal cuboid has dimensions 4 centimeters, 5 centimeters, and 20 centimeters. So in order to work out this question, let's just pop our dimensions on here. So we've got 4 centimeters, haven't we? 8 centimeters and 20 centimeters. The cuboid is melted down. The metal is used to make solid cubes, each with sides 3 centimeters. So we've got solid cubes, sides 3. And we want to work out how many complete cubes will be made. And we've got to show all our working. So let's think about what is the volume of the large cuboid. Okay, so when we're working out the volume of a cuboid, what we're thinking about is the base times the width times the length. Basically, we're multiplying these three dimensions. In general, for any prism, what we're doing is we're working out the area of the face, and then we're timesing it by the length. So 4 times 5 times 20. And this is going to give us 400. My units are going to be centimeters cubed because it's a volume. Okay, so I know how much I'm melting down. So let's just read through the question one more time. So the cuboid is melted down. The metal is used to make solid cubes, each with side 3 centimeters. Okay, so let's work out the volume of this cube. So very similar here. We've got base times width times length. This time they're all 3, aren't they? So 3 times 3 times 3, that is going to give us 27 centimeters cubed. So if we're melting down this large volume and we're dividing it into these smaller cubes, we're going to do 400. We're going to divide it by 27 to see how many we can make. So if we put that into our calculator, change it to a decimal, that's going to give me 14.81. And that will continue, 814, 814. It's recurring again. So the question asks us how many complete cubes will be made. So we've got 14 and a part, isn't it? In this case, we need to round that down. It's going to be 14 cubes. Two more questions to go. Got question 18. Asks us, so we've got a diagram here. We've got a north arrow. This is point A, point B, and then we've got an angle here of 55 degrees. It's asking us what is the bearing of point B from point A. So bearings, 3 things we need to remember when it comes to bearings. They go from the north arrow and they go clockwise, and they have 3 digits. Okay, so the really important thing, because we sometimes can get confused by the language here, it's starting from point A. So from point A, from the north arrow clockwise, is this angle. This part is labelled 55. This is a straight line, so this other part here is going to be 180 degrees. So 180 plus this 55, that's going to give me an angle of, or a bearing of 235 degrees. It's already 3 digits, isn't it? So that's perfectly good. Now it's going to ask us what is the bearing of point A from point B. So we need to move over to point B. Yeah, north arrow is not drawn in, so we need to draw it in. Okay, so there's the north arrow, and we're going to work clockwise till we hit that line going out to A. Just going to get rid of this line from before so we've not got anything confusing us. So what is this angle? So often these bearings questions will bring in angles in parallel lines facts. So these 2 angles, we think about parallel lines, they're related, they're alternate angles, they are going to be the same. So this angle here is going to be 55 degrees. Part B, the points P, Q, R and S are all 5 kilometers from point X. So P is on a bearing of 005 degrees from X. Q is on a bearing of 100 degrees from X. R is on a bearing of 240 degrees from X. And S is on a bearing of 355 degrees from X. So it's asking us which two of these 4 points, P, Q, R and S, are going to be closest to each other. So they're all the same distance, aren't they? So we've got space for a sketch here, so let's draw out a little sketch. Now when we're doing bearings, we always start with the north arrow. Okay, we're going clockwise, aren't we? From this north arrow. So P is on a bearing of 0.05 degrees. So if we think about, let's just think about our bearings. So if we've got north here, this is going to be 90, isn't it? This is going to be 180. And another 90 degrees takes us to 270, and then back here would be 360. Okay, so we don't need to measure it out. You can if you want, but it's just a sketch for you to think about this. So 5 degrees, that's going to be really quite a small angle, isn't it? So see, this is point P here. So 5 degrees. Q is on a bearing of 100 degrees. So I know that my right angle is 90 degrees, so it's going to be just slightly more than a right angle. I'm just going to make that a little bit shorter because it should be the same length roughly as P, shouldn't it? Okay, so there we go. That's going to be Q. So that's going to be 100 degrees. R is on a bearing of 240. So looking at where my 270 is, it's going to be something like this out to R. And then I've got my last one. So S is on a bearing of 355 degrees from X. So 360 is one full revolution rather, isn't it? So it's going to be just 5 degrees less than one full circle. So S is going to be around about here. So we're looking which two of the 4 points P, Q, R and S are closest to each other. So hopefully we can see from this diagram that we've got P and S are going to be the closest to each other. Only 10 degrees between them. Whereas we could work out, well, we could do it mathematically, couldn't we? Actually work out the difference in degrees around these other ones would obviously be much more than that, 10 degrees. Question 19. A bus is going to a Welsh Heritage Conference and it has 43 people on board. There are 38 students, 4 tutors and a driver on the bus. At the conference, each student will attend a lesson on language, a session on history, or both sessions. So all the students will attend at least one session. 18 students will attend both sessions. So it's always useful to start with the centre bit. Both sessions, it's going to be in this overlap, so there's going to be 18 students in there. Okay. 25 students will attend the session on history. So in total 25, if we take away the 18, we should find out how many is left in this only history section. So that's going to be 7 students, isn't it? The tutors and driver will not attend either of these sessions. So let's have a think how many of them are there. There's 4 tutors, 1 driver, and they're not attending any, so they're going outside of these circles. There's 5 of them. So we've got to complete the Venn diagram below to show this information. The universal set contains all of the 43 people on the bus. So we've filled in these sections here, haven't we? So we know that this bit in languages is just going to be, so we've got 43 in total. Let's see how many we've already filled in. So we've got 5 plus 18 plus 7. It's going to give us 30. And if we take that away from the 43, then we are left with 13 that only attend the languages. Okay, we've got one of the people on the bus is chosen at random. What is the probability that this person will attend the session on language. So what's the probability that they go to the session on language? So what we want to think about on the top of our fraction is how many students are going to attend the session on language. So we've got 13 here, haven't we? We've got 18 here. So in total, if we add those up, we've got 31. So 31 students attending the session on languages. On the bottom of the fraction, we just want the total number of people that we're choosing from. So we know the question tells us 43 people on the bus, so it's going to be out of 43. And that takes us to the end of this walkthrough. Thank you for listening.